I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 20th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we have a gale producing 40-foot seas southeast of New Zealand, actually forecast to build a little bit over the next 24 hours and producing swell. And on top of that, there is already swell in the water just poised to arrive in California as of this evening. So, things are looking better. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, that is a push in the jet to the north, and we really don't see it, but we have an area of decent winds here, 170, maybe 180 knots, pushing under New Zealand. We think that is enough to get the circulation going, a clockwise circulation. That's the hallmark of low pressure, both aloft and down at the surface. If it's strong enough, that generates winds. Winds, if they're strong enough, generate seas. Seas, if they're big enough, eventually turn into swell as they radiate away from the fetch area, and swell, when it hits your beach, turns into surf. So we'll call this a trough. It's really not. It's more like a strong zonal pocket of wind, but close enough because we know for a fact that there are seas being generated there. So we'll sort of, and there we go. As we move into Monday, starts pushing a little bit more to the north, but this really gives you the sense that the storm is just going to push flat west-east and not off to the northeast at all. And that's pretty much what we cheated. We looked at the models, and that's what we saw. But a pretty good run of energy pushing across the South Pacific into Tuesday, and then it starts falling apart. And then after that, well, it looks like another trough is trying to organize, but not really. The ice line's down here at about 61, something like that. Most of this is all over Antarctic ice. Probably no swell production. And then you see an out-and-out ridge. The energy's starting to push more to the south here as we get into Friday, and then reinforcing energy falling southeast for another, there we go, till then. And it's all over, though that almost looks like another trough maybe a week out trying to organize under New Zealand. But so for right now, it looks like the storm that's in the water is it for the next week. And we're starting to move towards the end of the season. The focus will turn to the north, and there's actually activity up there. We'll get into that in a minute. But for now, since the south has been pretty as much reliable as it can be, we're focusing there. So then we go down to the surface. Surface level pressure, surface level winds, as expected. Pretty broad gale here, 40-knot winds blowing out of the west, straight to the west, nothing to the northeast. So this will be a sideband energy type swell, especially for Hawaii. California may be a little bit better. The system, there we go, maybe a hint of a little bit of a southwesterly tilt to the winds on Sunday night, more so as we get into Monday. Then the gale starts fading out in Monday night. All moves pretty much out of the even the Southern California swell window. And that's pretty much it. We'll roll this out till, well, you see, literally nothing. We're looking for 40, 45-knot winds, nothing. There we go. So we get into Sunday, all aim straight south. Penguin storm, nothing for us, and we're 180 hours out. Now, maybe something might develop off the back end of this, but we're not holding our breath. All right, let's go take a look at significant wave heights. Now, as we said before, there is swell building in the water, supposed to be, Monday, Tuesday, Wednesday sort of thing in the California area. This is the system. It pushed under New Zealand. It had up to, I think, 42, 43-foot seas. Last frame of this hindcast only goes back a week. You can see it faded out. And then after that, there was a series of weak little blurbles trying to push under New Zealand, but they never really got decently organized until Saturday. And this is the system we're looking at now. This is Saturday yesterday, and it started building, what is that, 38-foot seas. But again, you watch the track here. We'll go back just, it's all just barely off the edge of the ice line. There's the ice. Was that 61, maybe 61 and a half south? something like that, making no northward progress, and that is, oops, let's see, we maybe have one more hiding under there. There we go. And that's where we are as of right now, 40-foot seas, highest seas over the whole domain, right there at 59.5 south, 166.5 west. Right there. Winds in that area, 45 knots. All right, let's move on. So the forecast for this system. All right, well, here we are, 18Z Sunday. Sort of get a little hint of a northward push, 40-foot seas as we get into Sunday night, into Monday, and then it starts to fade out. So this, regarding the shadow, the swell shadow, probably just eyeballing it, pretty much shadowed, but maybe some energy sneaking up around the Tahiti and the islands here, up around the southeast corner of the islands relative to California. Now we go out through the rest of the week. Some energy still pushing here into Chile and Peru. And then things, as we saw from the surface level pressure charts, really start dying out. There's nothing, all this aim due south. And so that's it. That might be the last semi-decent southern hemiswell of the season, but we'll see. There's always some sneakers that come in later. But we're in the combo swell season, both south and north. And there is a gale, as of right now, developing just south of the central Aleutians, 25-foot seas. But this is just the beginning. It's not supposed to be a huge storm, but building with 29.6-foot seas tomorrow morning, falling southeast, still with 28-foot seas into Tuesday morning, into Tuesday night, into Wednesday morning, into then fading to, 22, 24, 25-foot seas, even into Wednesday night, continuing into Thursday morning, and then fading out, pushing into the Pacific Northwest. You can actually almost see the leading edge of the seas impacting the North and Central California coast, so time that accordingly. It looks like a pretty good run of swell, and then maybe even the secondary system scheduled for Friday night, Saturday, has been on the charts, off the charts, stronger, weaker, hard to know, certainly much smaller than the main event. And there's something over here in the West Pacific and some sort of tropical system, but we're kind of ignoring all that for now because we don't really believe that any of it's real. Oops. And so there we are. But then, once we're into a week from now, looks like the North Pacific is pretty active, and we know the South Pacific is going to be all but asleep. So the transition of seasons looks like it will finally start to take place. Looking for wind swell down Northern California. Well, today there wasn't much. Maybe, waist high or something like that, exposed breaks. Hawaii, even less. Yeah, 20, 25 knot fetch off the coast. That is even supposed to die as we get into Monday. Nothing for Hawaii. Into Tuesday, you see why. Big low pressure taking over. All these local fetch, that's all generated by high pressure, and high pressure, 10, 20 millibars right here. Very weak, just being dominated by the low. And so you see the low working its way south winds into Oregon. This, we think, is going to be, this is a pretty typical early season pattern, but we think this is kind of going to be the drill for most of the winter. Everything northward displaced, focusing on the Pacific Northwest. We're looking for wind swell. Thursday night, some winds start building along California, stronger on Friday. That probably doesn't bode real well for the swell that's supposed to be in the water at the same time. Bunch of wind lump mixed on top of it north of Point Conception. Still nothing for Hawaii. And then we get into Sunday. So I'm actually looking down here at the gap. Let's see when the gap actually sets up. Looks like Saturday, mid-morning, something like that. So that's something to keep your eye on. Maybe lingering swell, decreasing wind swell, maybe an opportunity for some cleaner activity. Oops, and then we're into next week. So really not, maybe some limited wind swell Thursday, Friday, but that's kind of a mess because there would actually be real swell at the same time. Then precipitation. It would almost seem like there's a hope for precipitation as this low moves towards the coast, certainly for the Pacific Northwest. The first real precip of the year. Good for fire prevention, even down into, let's say, Cape Mendocino, but no further south, it looks like. And that's on Wednesday, Thursday sort of thing. And then high pressure taking up over California again. Big bout of rain, British Columbia, again coming in theoretically on Sunday down into Washington. So, again, looks like the storm door is trying to open. The Pacific's trying to wake up. Very northward displaced. Pretty typical, though, for this time of year. And especially in a La Nina type year, that would be the expectation. All right, let's go take a look at long term. What's going on with the Madden-Julian Oscillation? And, of course, the El Nino Southern Oscillation. Is it in the La Nina mode or the El Nino mode? Well, I think we know. As usual, we start by looking for the presence of the active phase of the MJO, the Madden-Julian Oscillation. This periodic weather oscillation, it goes the whole way around the planet from west to east. Active phase on one side of the planet, inactive phase on the other side. But when the active phase pushes over the Pacific and it travels on the equator, west to east. When the active phase is in the Pacific, it's like a low pressure pool, creates clouds. It changes the trades from east to west if it's strong enough. It imparts energy to the jet stream, which feeds the storm track, which then, of course, produces surf and snow and rain when it's south of wherever your location is. But the key for imparting energy to the jet stream is when the active phase is over the West Pacific, over what we call the Kelvin wave generation area, because it not only imparts energy to the jet stream, it also can create a Kelvin wave. And if you get successive Kelvin waves, which are like pools of warm water, pockets of warm water that travel under the equator from west to east, they hit Ecuador, and that can be the kickoff to El Nino. But we don't think we're anywhere near that. We're nowhere near even getting a strong active phase of the MJO to create a Kelvin wave. But anyway, all right, so let's inspect winds. We're looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. We're looking at the arrows, 5-day average winds. The longer the arrow, the stronger the winds. Strong easterly trades blowing over the East Pacific, Central Pacific, and then into the Kelvin wave generation area, the far West Pacific. That area from that's New Guinea right there. Date line's right there. The equator's right here. So this box from 135 east, 5 degrees north and south of the equator to 170 west, right in there. And when you get the active phase there, if it's strong enough, lasts long enough, it creates west anomalies, and that in turn can take this warm water, the orange colors you see here, start pushing it east under the equator in the form of a Kelvin wave. All right, but it's anomalies, differences from normal that really matters. We see strong east trades. What are the arrows saying? Yeah, even here, if they're easterly, that's saying the trades are a little bit stronger than normal, a little bit stronger than normal over the Central Pacific, and moderately stronger than normal over the Kelvin wave generation area. So this is a good, pretty typical sign of the inactive phase of the MJO. And the inactive phase does just like the opposite of the active. It sort of does not impart energy to the jet stream, does not form Kelvin waves, and isn't great for swell production. That said, we have a storm down south, and we have a storm up north. So there isn't always a 100% correlation, thank goodness. All right, zonal wind forecast. What are the east or west components of the wind going to do over the next week? Okay, this is a GFS model, GFF operational forecast. Whole planet on one chart. 180 is the date line. Okay, the far West Pacific Kelvin wave generation area runs from about here. You just go right up the chart to 170 west to right here. Okay, so between here, and then New Guinea. Ecuador is like over here somewhere. The blues, purples, strong east anomalies. They've been going on, well, you can see since August, all of September so far, and continued forecast till at least September 27th. Inactive phase of the MJO might be more than that, might be more like La Nina. When you get these extremely long runs of easterly anomalies, it's driven by something more than the MJO. And the same thing happens during El Nino. When you get extremely long runs of westerly anomalies, like these reds right here in the Kelvin wave generation area, then that is just nonstop Kelvin wave production machine, nonstop energy transport to the jet stream to produce storms, and the result is nonstop surf. Unfortunately, that is not the expected result for the coming season. Anyway, all right, so MJO, the longer outlook, we go out 2 weeks now, right? Outgoing long wave radiation, OLR. Remember we said when the active phase is over the Kelvin wave, it's like low pressure, it creates clouds. Well, the blues are cloudy, more cloudy than normal conditions. So weak active phase per the statistic model over the Kelvin wave generation area. That's South America, Central America. EQ is the equator right there. And it's from one Kelvin wave generation, one area 170 west over to about 135 east, so right in there. Weak, cloudy, more cloudier than normal pattern, weak active phase of the MJO expected 5 days from now, 10 days from now, building to modest category 15 days from now per the statistic model. Now the dynamic model, not nearly as robust, just a very middling, weak active phase forecast for the next 2 weeks. Phase diagram charts, another way of looking at the same data. Okay, this is the statistic model, this is the dynamic model. Assume this is the North Pole. You're looking down on the North Pole, and the MJO travels on the equator around the outside of the chart here, around the equator. From the Indian Ocean, west to east, over the maritime continent, like Bali, over the West Pacific, East Pacific, under the United States, like the Gulf of Mexico, over the Atlantic, over North Africa, back to the Indian Ocean. Wherever the active phase is, the inactive phase is 180 degrees on the other side of the planet. Heavy dots where the active phase is, so the maritime continent's there, according to this, and the inactive phase is, well, maybe over far East Atlantic. So the forecast per the statistic model, 2 runs have it, or 2 members have it moving into the West Pacific over the next 2 weeks, but very weak. 1 member, pretty strong. The dynamic model says somewhere in between the two. The active phase just sort of meandering around in the far West Pacific. So that's pretty consistent with what we saw in the other charts. Nothing, no robust active sign, but that's better than the inactive phase of the MJO. All right, the upper level model. Greens are areas favorable for precipitation, reds not favorable. Reds, one can equate to the inactive phase of the MJO. Greens, the active phase. All right, South America there, Central America there. Here's the equator. New Guinea there. Philippines there, Kelvin wave generation area right there. So this looks like and this runs about a week ahead of what happens down at the surface. Very strong inactive phase pushing into the Atlantic, pretty much gone. Very, very weak active phase, forecast dribbling through the Pacific, pushing out from now into about, we'll say somewhere around here, mid-October. And then it moves into the Atlantic. Here's when the Atlantic hurricane season should really go do its thing. This would be probably big northeasters along the southeast U.S. coast in the October time frame. And then the inactive phase, pretty weak. This is a statistic model, though, pushing into the Pacific through mid-October into late October. The 1 month CFS model, so this is interesting. Again, whole planet on one chart, date line right there, Kelvin wave generation area from here to about here. So you can just go down. The blues are easterly anomalies. One would say the inactive phase of the MJO. It's a little piece of it in the far East Pacific, and you see lots of east anomalies. No real MJO, no coherent MJO signals, just east anomalies into, end of September, maybe a little dribble of westerly anomalies, not enough to probably do anything for storm production. Then you get into late October, easterly anomalies forecast picking up again, inactive phase of the MJO, we'd say, even though it doesn't say it. So maybe it's just a pulse of La Nina, and nothing obvious suggesting any significant support for storm production or a catalyst to really make it blow up. And then the 3 month CFS model. So this is the forecast is up top, past performance is the bottom. Kelvin wave generation area starting here, the whole way up the chart to 170 west right here. And just looking up, you see blues, that's easterly anomalies. I see now the Kelvin wave, these are easterly anomalies forecast now into about mid-October. Then a little bit of westerly anomalies trying to take over the Kelvin wave generation area, but strong easterly anomalies forecast in the East Pacific for the foreseeable future. Let's overlay the MJO, see what we get. All right, inactive phase fading out. Oh, weak active phase, just like the other models we're saying right now, but so weak as to still the base La Nina state is basically overpowering the active phase of the MJO. So we have a continuation of east anomalies. Then you get this sort of weak, fragmented, inactive phase of the MJO setting up, October-ish to mid-October, according to this. Easterly anomalies in control, but only from the dateline eastward. Then the active phase is supposed to come in later October with pretty decent, now this is not in the Pacific. The Pacific starts right around here. So limited westerly anomalies, mainly easterly anomalies in control. The MJO just cannot get over the La Nina base state. So let's overlay the low pass filter. Here you go, and this is the explanation why the dotted contour is the high pressure bias that is the hallmark of La Nina, with one, now two contour lines that set up, what was that, 12th of September, something like that, and is forecast to continue for the foreseeable future. The low pressure bias, which has been in the Atlantic for 2 years, is now setting up in the Indian Ocean, feeding all the storm development there. Low pressure supports storm development, high pressure does not. Now, it's supposed to build strong enough that it actually kind of nudges into the West Pacific. What is that? Just eyeballing it, maybe about 165 west. So moving into the Kelvin wave generation area, and the high pressure bias sort of getting shunted out. So this opens a little opportunity as we get into late November and December for the far West Pacific to get pretty active. So that could be some really long distance, maybe longer period swells for exposed breaks in North and Central California, but probably from a pretty north direction. Assuming all this to be true, and this is a model that goes out 3 months, so take it with a grain of salt. But that's what we're sort of clinging to anything we can get our hands on. And with that, let's move from the MJO, which is more of a short term, like a 4-week, 6-week kind of thing, to what's going on with ENSO, La Nina specifically. All right, we start out by looking subsurface temperature profile. This is the West Pacific here, East Pacific here. These lines here are the TAO buoys. The X's are sensors on the buoy anchor lines. They're strung the whole way across the Pacific, used for monitoring El Nino. But you take the data from these sensors, run it through a model, fills in the gaps, and you get a profile of what the subsurface temperatures are doing on the equator. From west to east, warm water in the West Pacific, much shallower region of warm water and not nearly as warm in the East Pacific. This is pretty typical of a La Nina pattern. Trades are blowing much harder than normal. There's no Kelvin waves, nothing to take this warm water here, transport it to the east. So temperatures would be below normal off of Ecuador. Lots of upwelling, great for fishing, great for the marine life there. Not so great for feeding storm development. Everything is focused in the Indian Ocean. But it's not the actual temperatures that matter. It's the anomalies, differences from normal for this time of year. And we see basically the same sort of pattern going on. Almost, it looks like, trying to be a Kelvin wave, making it was about 160 west. But a large area of 2 degrees Celsius below water, so it's about 3.5 degrees Fahrenheit below normal, filling basically from the dateline the whole way into Ecuador. That's thousands of miles of water of below normal surface, subsurface temperatures, and also you see them breaking to the surface. Trades nuking here, upwelling, that's the name of the game. We do not think this is a Kelvin wave. Here's another model using the same data. Paints an even worse picture. 1, 2, 3, 4, 5. We'll say 6. 1, 2, 3, 4, 5, 6. 4 degree below normal temperatures here. Again, filling from 165 west. The date line is out here. The reality is it's even west of there. The whole effective equatorial Pacific is drowning in colder than normal water. Classic, typical La Nina sign. Warm water all balled up in the far West Pacific or into the maritime continent. Sea surface height, not temperatures, height. Is the surface of the ocean higher than normal or lower than normal? Well, why does that matter? Well, if you have cold water at depth, cold water contracts, creates a divot on the ocean surface. If you have warm water, it expands, creates a bump on the ocean surface. You can measure the height of the ocean surface with the JSON-3 satellite, and if you strip out the waves, strip out the wind waves, strip out the tide, you see a minus 10 centimeter, almost minus 15 centimeter depression filling. Well, that is Peru, that is Chile, that's Central America. You get the picture. The equatorial Pacific, the whole way to the date line, it has colder than normal water under it, and then you get west of the date line, it's warmer than normal water. We know that trades are blowing extremely solid and have been for quite a while over this area, taking all the warm water that was there and just bulldozing it off to the west. And that is, again, the hallmark of La Nina. All right, so let's go take a look at the surface, and it is not a pretty picture. It is, the blues are colder than water temperatures. This is really, it's not two streams, it's one stream. The images are kind of offset. We're trying to put the tiles together to give you a broader perspective of what's happening. Higher res data. There is Ecuador, cold water, just continually deeply cold in pockets, moving off the whole way to, where are we there? That's the date line right there, and beyond the date line. So the entire Pacific is cold, and the coldest of the cold water is due south of California. That's where the strongest of the high-pressure bulge would be. If you're going to overlay the jet stream, or what we think it's going to do this winter, it would just come from off the picture and be rising and rising and rising as it the whole way up over California, and then diving into the coast somewhere inland, maybe even further over here. And that is pretty typical La Nina. The 7-day trend, the blues are colder than normal, right on the equator. Yeah, there's some warm pockets here, but you can see colder trend the whole way from just off Ecuador, the whole way out to the date line and even beyond. Now, this is just 7 days worth. You know, it pulses, and so what we're really watching here is the pulses of La Nina. It surges, then it'll back off for a week or two. Then it'll surge again and back off. Some of it based on what the MJO is trying to do, and that'll feed it. You know, so when you get the active phase of the MJO pushing over, even though we have a base La Nina state, it'll sort of take the wind out of La Nina's sails, and it'll sort of settle down for a little bit. East anomalies will back off. Water temperatures will try to rise a little bit. And then the inactive phase, or whatever there is of it, will pop up, and then the machine starts cranking, and you get another cold pulse. And it's the exact opposite of what El Nino does. You'll have warm pulses, lots of energy. The cold pulses in La Nina, pretty much just stomping on storm production. That said, we still see something on the chart, so all hope is not lost. All right, and then the current backed off view, September 19th, 2020. Cold water in control from, oh, there's Ecuador, a little pocket of warm water right there, but you can see. So there's high pressure here, circulates counterclockwise in the southern hemisphere. High pressure in the North Pacific, circulating clockwise. When you're in a La Nina pattern, they're stronger than normal, so you get this increased easterly trades, and you can see the effect here. It just sends a dagger of cold water into the heart of the West Pacific and warm water to the north and south. It's parting the waters and driving warm water north and south, and you go, oh, that's great, but the reality is it's the temperatures right here that have everything to do with jet stream level circulation, global circulation, and where the warm waters are on the equator, that's where the storm production is. And take a look over here and a little bit here, but the focus really looks to be the Indian Ocean. So we did a little comparison with the last La Nina we had. This was in 2017 on September 19th. Check that out. Now we'll just pop that away. You can see that it is, whoops, where'd we go? There we are. Much weaker, this last one that was in 2017 as compared to what's happening this year. All right, so if 2017, now let's go see what the peak happened during 2017. Here was the peak of the December 19th, 2017, and it looks very much, I'm going to pull that out of there. This was the peak. Now here's what we have today. Look at that. It's not even as strong as what's currently happening today, suggesting that when this thing fully reaches its peak in the December time frame, it will exceed the last solid La Nina we had just 3 years ago. Why is that? Well, I kind of suspect that this La Nina in 2017 didn't fully discharge. I mean, there's still been like this lingering El Nino energy in the atmosphere that's been going on even like last year and the year before that. So we had a good El Nino in 2014, 15, 16 time frame. Pretty strong. Took a while to get its act together. And then we had this discharge La Nina for 2 years. But then like El Nino almost tried to come back for 2 years. And now we're finally getting the real discharge from that. It was part of it was last year and now this year. We think it's finally going to get it out of its system now. And then we'll probably, we're guessing, we're hoping, return to a neutral base state as we get into 2021. Sea surface temperature analysis, Nino 1.2 region, the area right there up along of Ecuador, the Galapagos, hasn't been changing. We lost maybe half a degree over the past 3 months. Today's value minus 1.814. That's pretty cold right there, and has been holding more or less there for the past month. In the official El Nino monitoring region, the CFS model had projected a precipitous drop. We were kind of saying, nah, maybe not. But looking at it now, today's value minus 0.894. Keep that in your mind. There's where we are right now, 0.894. But in a minute, we're going to go look at some projections and see if we're on track or not. So let's say 0.9 right now. Sea surface temperature anomalies in different regions. The Nino 1.2 region, that's that area right there by Ecuador. According to this is, it's hard to tell, but about minus 1.2, something like that. Nino 3 is a little bit further off to the west, almost minus 1.2 degrees. The official El Nino monitoring region, minus 1.0 degrees. We just said minus 0.9, so these are about in sync. And then out in Nino 4, which is out towards the date line, what is that? 0.25 or something like that. But this is the one here that really counts. You can see the trend steadily downwards. In fact, even in Nino 3, even in Nino 1.2, all suggesting a building La Nina pattern. And then what's going on in the atmosphere above the ocean? Does the atmosphere sense that there's cold water? Does the atmosphere sense that high pressure is building? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When they index, there's 3 different indexes, the daily, the 30, and the 90-day. When the index is positive, and strongly so, that suggests La Nina. When it's negative, that suggests El Nino. El Nino means lower pressure over Tahiti. La Nina means stronger high pressure or high pressure building over Tahiti. Today's value, plus 13.73, and that's definitely positive, suggesting high pressure. And just scanning down through here, we've had nary a negative reading in a month. The 30-day average, 8.85 today. We were up at 10 there a couple of days ago, and have been, you see a month ago we were at 0.6, went up to 10, but we're pretty much floating right around the 9 or 10 region for the 30-day average. The 90-day average, but remember, this is a 30-day lag too. So this is really saying what's been happening the past 30 days, not what is happening today. The 90-day average was down at neutral a month ago. It's now at plus 6.31, and again, it's a lagging indicator. All these suggesting a push now towards La Nina. The 30-day average SOI on a graph, you can see it plain as day, moving positive, no hope. Remember we were talking last, January, April timeframe, we were negative, strong pushes of the active phase of the MJO, suggesting, hey, maybe we're, moving into some sort of a weak El Nino pattern in 2019. And then as soon as we came around the corner, it was actually like November, December, you could see just a steady upward trend started. And now you see this? There has been nary a active phase of the MJO since July. It's all been steadily upward. Again, more evidence suggesting the arrival of La Nina. Then finally, the official forecast from the CFS model for sea surface temperatures in the Nino 3.4 region, the official El Nino monitoring region, and it's actually updated pretty well. All right, so last year, January 2019, this was sort of this warming, 0.7 a degree above normal. It didn't really do much for the surf. If anything, it was a lackluster year, but it sort of hinted at, well, at least we're warm. That's better than being cold. Then we got into this summer and we were hovering around neutral. July, the model said we were going to fall into a hole. It actually is kind of pushed out a little bit longer than expected. As of today, we are, the 20th of September, so somewhere right around here. And we said 0.9 on the other chart. That's what the model's saying. The model's saying we're going to dive the whole way down to minus 1.6 degrees in the official El Nino monitoring region come mid-December, something like that, mid to early December. That's pretty cold. That's a pretty strong La Nina. And then a strong rebound as we get into the fall, into the summer of next year. That'd be good. But the net effect is by the time you're down here, it's going to take you probably 6 months. Well, 3 months from the time you get to here before the atmosphere finally goes, oh, it looks like all the forcing that's driving the La Nina pattern's over. So it wouldn't be till, if this is June to July, August, it wouldn't be till next fall to where the La Nina washout starts to happen. And it could be even another 3 months beyond that. So we just got to grit our teeth and bear it right now. This is going to be one of those years. It's payback time. We've had off and on pretty good runs of surf at time. And again, just like you're seeing right now, there's still surf. It's just your strategy should be, if there's waves, go get it. Don't, like, oh, maybe I'll go tomorrow. If it's rideable, go surfing, because these storms will not be super consistent. They will not be long lasting. The swells they generate will be kind of fluky, and you get what you get and try to make the most of it, and just set your sights low, hope to grovel, and if you get something better than that, then you consider it a score. All right, so for right now, there's good news. There's southern hemiswell starting to hit California, and there should be swell for a couple of days. That's great. And the models say there's another storm with developing, so that should arrive in Hawaii about a week later, and here about 9-10 days later, something like that. So that's good news. And there's a gale starting to organize in the northwestern Gulf of Alaska. That should bring a pretty good run of swell as well. A couple of days worth, and maybe some wind swell mixed in with that. So again, like we said earlier, there's a window here. Make the most of it, because you don't know when you're going to get that next window, and enjoy it, hold on to it, and, just know it's a La Nina winter, and that's just the way the game's going to have to be played. All right, so if you enjoyed the video, thanks for watching. Give us a thumbs up. We surely appreciate it. If you haven't subscribed, please subscribe. Hit the subscribe button. You'll get an email. Comments. If you have questions, don't understand something, a lot of this stuff gets really deep real fast, write in the comments. We'll be happy to try to explain a little further or point you to resources. All the data that you see here on the forecast is available on stormsurf.com. Just sort of root around, you'll figure out where it is. Buoys, weather models, all the El Nino dashboard that we show, all that kind of stuff. And if you don't want to do any of that stuff, you just like the videos, we post a link to the video after we produce it up at the top of the site, and you can just watch it there weekly, Sundays, typically in the evening. All right, thanks for watching. We'll do this again next week. Same time, same channel.